All right, welcome to day 3 of scatter plots. Let's go ahead and start with slide 2. Day 2, we ended with writing equations for lines, and now we apply that onto an actual scatter plot. So when a scatter plot has a strong association, a line of best fit can help you analyze data and make predictions. Extend the line of best fit to find the y-intercept. Choose the 2 points on the line and calculate the slope from them. Use the values to write the equation. Okay, so I am going to first click on my blue line here and grab this end. I moved my line a little bit. No. All right, try not to move your line. There, I got it back pretty good. Okay, so if you extend the line, and really I don't know that you need to extend it to figure that out, it looks like it goes right through 60. So that is easy. I'm going to type in 60 for the y-intercept. So that's a test score of 60. Now we're going to use 2 points on the line indicated by the yellow arrows. And remember that the scale is not counting by ones. Okay, so let's look at the scales for a minute and also just observe. We're going to find our slope between these 2 yellow arrows because that's exact points, pretty close to exact points on our line. So we're not actually using any of the red points to do our slope from. Okay, so the scales, what's the y scale being counted by? If I look at this line here is at 60 and this one's up to 80, right? 60, 70, 80, 10s is too big. So I would try 5s next, 60, 65, 70, 75, 80. So the y scale is being counted by 5s. And the x scale is a little more complicated. Hours studied. So if I put my little plus here at 1 and I go up to 2, that means these lines in between are some fractions or portions of time between 1 and 2. So maybe the easiest way to do it is to go right halfway through because that would be 1.5 hours studied. All right. And then halfway from 1 to 1.5 would be 1.25. So each one of these lines is being counted by 0.25s, right? So this is 1, 1.25, 1.5, 1.75 hours, and then all the way up to 2 hours. So when we count our slope, this is the trickiest part of the whole procedure. We can't just count up, 4 over 6, right? We're counting up by 5. So we're going to go up 5, 10, 15. So we went up 15. And now we're going to go over 1. I don't need to count all those in between because I know over to this line is 1. But that first mark after 1 is 1.25. All right. So I counted up 15, I think. Was it 15? Let me check one more time. It's 5, 10, 15. Oh, 60, 65, 70, 75. Yeah, by 5s, right? 5, 10, up 15. So that's my rise. And my run was 1.25. And then I would just, because it's weird numbers, and this is kind of how it is with real life, slopes are usually not just simple fractions like we always graph them in algebra. So we're going to just in our calculator hit 15 divided by 1.25 and we get the number 12. Well, that was a very friendly number, 12. But don't be surprised when you do that if you get a very strange number. Sometimes the decimals are like 0.00376 for the slope, Okay. So when we write our equation for the line, it's y equal mx plus b. So our m is the slope of x plus 6. All right, let's move on to slide 3. It's the same graph, it's the same scatter plot. So I want to recopy my equation because we're going to use it. So I'm grabbing a text box and I'm going to fill in y equals 12x plus 60. All right, I'm just keeping that in mind. So now it says use the line of best fit. Actually, let me back up a little bit. It says the line of best fit itself can be used to look at for predictions when you are interpolating And the line of best fit will help you make predictions when you are extrapolating. We'll review those in a sec. Okay, you can always use the equations if you prefer. All right, I'll show you what that means. It says, using the line of best fit or the equation you created, predict the test scores of the students who studied for the following amounts of hours. All right, so 1.5 hours, I'm going to put my little plus right there at 1.5 because that data is within our graph. I can track up to the line and make a prediction about what the test score would be of somebody who studied 1.5 hours. That was called interpolating. All right, there's no dot there, but I'm just going up and it looks like my little plus sign is pointing at about 70s, between 75 and 80. So I would say about, 77%. 77% for that person. All right. Is 2.5 hours on my chart. So here's 2.5. It is. So this would be interpolating one more time. So somebody who studies 2.5 hours should get a higher score. So I'm going to go all the way up. So here I'm using the line to interpolate. Okay. So that's pretty close to what, 80, 85? That's pretty close to a 90% on the test, right? If I track my line over to the y-axis, 90%. So here's where we extrapolate because 5 hours didn't make it onto the chart. So what we would need to do would be to use the equation. I'm going to give some space here, see if you can fit this in or not. But here's how we use the equation. So if I know that somebody studied 5 hours, I would use my equation and say 12 times 5 plus 60 equals, and then I just punch it in my calculator, 12 times 5 plus 60 equals 120%. Does that answer make sense? Not really. It's hard to get 120%, at least on a math test. Sometimes you get a little extra credit, but not really. So that's these two follow-up questions are addressing this. Is the equation created always going to assist you with reliable predictions? No, because 120% really isn't very reliable. Describe when the equation appears to be no longer valid. So when you think about it, when you look at this line, theoretically, people who study, whoa, that blue line kind of goes off the chart at 3.5 hours. So theoretically, according to our line and our equation would give us the same information. A student who studies 3.5 hours would be scoring at around 100%. So anyone who studies more than that should get over 100%, but they won't, right? They'll get 100%. And that's a maybe. So the equation appears to be no longer valid after 3.5 hours. As students will not be able to actually score over 100%. Unless the teacher puts on a little extra credit, but that's not related to study time. All right, let's go on to try one more. So first we just look at the chart and we are going to just answer these questions. Does it appear to be linear form or non-linear form? And I would say it looks linear. It looks like I can draw a line downward from that. It's a negative association. So let's delete out positive, Control Z whenever you delete something you don't want to or do something you don't want to. Right, negative association, if I were going to draw a line, it would go down from left to right. Any outliers? It does not appear that there are. There was an outlier on our last chart. I didn't mention it, but we didn't really do anything with it. So you don't need to worry about outliers anyway, except to know to ignore them. Okay, and then the R value, I mean, it's fairly strong. We've really only been dealing with a couple numbers. So I would rank this one as a 0.9, maybe a 0.8 if you wanted to get super technical. And what is this chart telling us? It is telling me that the more absences a student has, the lower their class grade will be. All right, so if you read the chart, more absences gets paired with lower grades. Okay, now we're going to do the more technical stuff with this. So we're going to try to use the line tool to draw our line of best fit. All right, I'm extending the line of best fit through the y-axis, so we can find a y-intercept. Then we're going to choose 2 points on the line to calculate the slope, and then we're going to use the values to write an equation. Okay, so here's the line tool up above. And I'm just going to try to make my line about there. Do I have about the same number of points above as below? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I mean, that's looking pretty good. Okay. Okay, I paused it and magically made these yellow arrows appear on this screen. So hopefully they'll be there when we actually do it in class, but and when you have them. If you don't have them, just watch me move these arrows. So that's approximately the y-intercept. So I'm going to place one arrow there. All right. And this, I'm looking for an exact line or point. I mean, it could be different on yours, but I do kind of have one right there. So when I count the slope, well, let's do y-intercept, 100. Okay, and now we're going to count the slope, keeping in mind that we are going to count down, not by ones. What are we counting down by? Let's see. These look like they go by fives again. 40, 45, 50, 55, 60. So we're going to count down by fives. 5, 10, 15, 20, 25, 30, 35, 40. Okay. So I know that my down, I'm going to put it already. I rised down 40. All right. And I'm going to run. At least this is counting by twos, it looks like. So that's what, 2, 4. So we can just actually count take the number from the grid, right? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 18. Oh my gosh, look, it says 22. What happened to the line? 18, it jumped from 18 to 22. I'm just going to say 20. I think that that's more accurate. Well, maybe I'll say 22. I don't know. That's a discrepancy. Do you see what I'm seeing down there, you guys? It jumps from 18 and then somehow they left 20. They skipped 20 and it went to 22. That is unfortunate. All right, I'll say 22. Okay, so we're going to do negative 40 divided by 22 on our calculator, and we get negative 1.81. All right, so here's our equation, right? We put the slope first, negative 1.81. So that's our m, x plus b. Okay, so now we'll take that equation. I'm going to keep it in mind, negative 1.81x plus 100, and go on to slide 6. And I'm going to write it, make a text box, and I'm going to write it up here. Y equals negative 1.81x plus 100. And that's what I might need to use for my points down below. So this kind of lines it out for us. Oh, I lost my line as best fit. Let me go get that line. Copy from the other page and paste it. And oh, it puts it in the same spot. That's lovely. Okay. So hey, go pause the video if you need to. Go back up, copy, and then paste your line down on this screen. So let's go ahead and use the line to interpolate. 12 absences is right here. And I'm just going to track 12 up to the line. And it is boy, it's about 75, maybe 76%. 76%. All right. How about 18 absences right here? So we put um, our cursor on 18 and we track up to the line, and that's interpolating. So according to our line of prediction here, we would be at a 60, 65. It's a little below 65. So maybe I would just approximate 64% for mine. Okay, to extrapolate means that we would have to use, because we don't actually have 35 on our chart. So we're going to use our equation, right? Negative 1.81 times, and our x value is 35, right? So do you see that our chart doesn't go up to 35? So we can't just interpolate. We can't just read it off our chart. Times 35 plus 100. All right. And then I'm going to go ahead and just punch that in my calculator. Negative 1.81 times 35 plus 100 is 36.65. So I would round that to 37. 37, and we're talking about the class grade, so that somebody with that score would have a 37%. All right, and we do the exact same thing for this one. I'm going to pause and do it, and you guys can go ahead and pause and do it on your own, and we'll compare answers in a minute. Okay, so I plugged in 42. That's our absences, right? So we plug 42 in for the x in our equation, and I got a 24%. So you can imagine that this line of prediction becomes unreasonable once if you got a lot of answers. You would maybe even start getting negative class percentages. A lot if you had a lot of absences. So maybe if you put in like 200 absences, that wouldn't even be possible, right? We don't even have that many days in a school year. All right. So let's go ahead and move on to slide 7 and see what that's all about. So now we're just kind of looking at this, which there's not going to be a way to actually make predictions about this. All right. It says, we'll start with our little mental relationship. Is it linear or nonlinear? So this one is nonlinear. Okay. Let's see, does it have a positive, negative, or no association? Good question. It's not positive or negative. It kind of looks like it's both, doesn't it? I think it does have an association. Okay, just wanted to verify. This has a non-linear, we'll call it a non-linear association. It does have a clear relationship. It just isn't linear. Are there any outliers? No. And approximate the correlation coefficient. And we say not able to do for non-linear. Okay, so if it's not linear, there's no correlation constant for it. But the chart is definitely telling us something here. And that is, let's see, it's about fertilizer used and crop yield. Okay, so it's kind of like one of those too much of a good thing is not a good thing. Fertilizer, plants like fertilizer up to a certain point, and then if you overdo the fertilizer, the plants don't like it. So I think that's what this is telling us. Up to a certain number of pounds on a crop, right? Up to, it looks like about what, 100, 105, 10, maybe 115 pounds of fertilizer for this crop size was nice. Anything over 115 pounds, this crop did not like it. It had a smaller yield. Okay, so what can we say? The crops did did well up to about 115 pounds of fertilizer, but after that, the crop yield. Okay. Okay, and slide 8, mentally describing the relationship. All right, so we'll go through the kind of those same analysis questions. It is nonlinear. This is one we can truly say appears to have no association. If there's no association, then you wouldn't have any outliers. The correlation constant R cannot find this. Actually, I said that wrong. We can find it. These are the ones that have a correlation constant of 0 when there seems to be no correlation between the two variables. So this one is truly the one that's 0. Okay, and what this chart is telling me is that there appears to be no relationship between shoe size and number of text messages. There's no relationship between a person's shoe size, number of. All right, that looks familiar. I think we've had this slide before. Something similar. All right, and now it looks like we get to try it one more time. I'm going to go ahead and pause the video and kind of go through this, and you guys can try to do it on your own and decide what if your answer and my answer are pretty close in the end. Okay, so it looked linear to me. It looks negative to me. I didn't see any outliers. Well, maybe there is one outlier. Maybe this fan that traveled 80 miles. So maybe one at 80 miles. I'll put the coordinate at 80 miles who traveled traveled 80 miles, and there were a lot of home games. There were a lot of fans. Sorry. I had to pause and count out my Y scale. It looks like about 250 fans went to a game that was pretty far away. Okay, and approximate the correlation constant. Looks to me about close to a good line, but not perfect. So I gave it a negative 0.9. And the chart was telling me that the further that people had to travel to watch their home team, the fewer fans that went. Okay, last slide. We'll go ahead and try to get our line of best fit on there and find our coordinates and then answer these questions. Okay, good job if you endeavored to get through all those questions. That was a lot of work. So I brought some yellow arrows over to show where I counted my slope from. I got a slope of -5, y-intercept of 550. And I went through, I interpolated on all of them except the 100. And I kind of got stuck on that 100 miles away because it looks like after 100 miles away that my number of fans should be negative. But I still got positive 50 based on my equation, right? I had to extrapolate this. I had to use my equation. And that is because there is this gap in data, right? All of these are being counted by 25, 25 fans, right? Every line is 25 fans, but from here up to here is 225 fans. So that would explain why the line doesn't match the answer that I got. Okay, and then the last question was at a home game that the distance traveled would be 0 miles. That means you're staying at home. So that would just correspond to the y-intercept of 550 fans. Good job if you got through all of these. That was a lot of work. Don't forget to turn them in to me. Find this in Canvas and submit it through your Google Drive.